Chemistry with Coach Chase.
Founded in 1667 by Robert Boyle, Boyle's Law helps us to understand how a gas works, how it behaves when the temperature is constant. That means the temperature does not change, okay? So we're looking at pressure and volume and how the pressure responds to a change in the volume, okay? So if you remember, pressure is the collisions between the gas particles flying around and the actual container. The more often they hit the container walls and the more energy they hit the container walls with, the higher the pressure. Boyle's Law helps us to understand what happens to pressure when the volume changes. So if the volume increases, what do you think happens to the pressure? If the volume decreases, what do you think happens to the pressure? All right, check out the simulation here. It's a Phet simulation. Google it, Phet, Phet simulations. They are awesome in showing how chemistry works. All right, so here we have a gas simulation where we're going to examine Boyle's Law. Now remember, Boyle's Law says that if temperature, right over here, is held constant, which means our temperature is not going to change, okay? So if you look right here, this is our thermometer. That is our temperature reading. That number will stay the same. We're going to keep it at 300 Kelvin. And if you don't remember, Kelvin is just another unit of measurement for temperature. So you have Fahrenheit, which we use here in the US. You have Celsius, which they use pretty much everywhere else. And then you have Kelvin. Okay, and we like Kelvin because Kelvin has no negative numbers. So when we do our math, we don't get crazy negative volumes or pressures or temperatures. Well, I guess you can't have a temperature, but volumes and pressure. All right. So if the temperature is held constant, the only thing we can look at are pressure. And here's our barometer that measures our pressure. Right now it's a reading anywhere between 11.4 and 12. And this box here represents our volume, okay? And so there's a handle right here on the left side. I can move the handle out or I can move the handle in to either decrease the volume, or if I move it out, we'll be increasing the volume. So as I move this out and in, I want you to take note of what's happening to our pressure, okay? If the volume increases, what's going to happen to our pressure? Let's check it out. We're going to increase the volume. All right, let's be dramatic. Well, I think that's as big as it goes. What you'll notice is when the box got larger or the volume got larger, the pressure decreased almost by four and a half points there. Okay, so as the volume increased, the volume went up, the pressure went down. Volume went up, it increased, the pressure went down, it decreased. Okay, well, let's see what happens when the volume is decreased. Based on that, take a guess right now in your head. Based on that, what do you think is going to happen if we decrease the volume? What's going to happen to the pressure? All right, we're going to decrease it and make it as small as we can. Do you think the pressure is going to increase, or do you think the pressure is going to decrease? Here we go. Wow. So you see, as we decrease the volume, we made the box smaller, the pressure jumped way up, right? It doubled what it was initially at the beginning, okay? And so what that means is that these two are opposites. If I increase my volume, my pressure decreases. So volume goes up, pressure goes down. And or if I decrease the volume, the pressure goes up. Now, the reason why your pressure increases is because there is a increase in the collisions. There's less room. It's more tightly packed, and so they're going to hit the container walls and each other a lot more frequently than they did previously because there's less space. All right. If we increase the volume, way more space, not nearly as cluttered or congested, and the pressures are a lot lower. All right. So think about it like this. Think about going to the mall. Okay. You're going to the mall to your favorite store. If it's holiday season, then there's going to be a lot of people there, and it's going to be tightly packed. The opportunity to hit other people and come in contact with other people, and when I say hit, I don't mean like physically ball up your fist and punch them, but if there's a lot of people during the holiday season, there's a high probability that you're going to hit more people. You feel more pressured, you feel more impacted, you feel more closed on, right? Whereas if you go on a Monday or a Tuesday, there's nobody there because they're there the weekend. So you've got a lot more space to go and shop. There's going to be less pressure. All right. It's a more comfortable shopping experience if you don't like being around a lot of people. Some of y'all like going to the stores, to the malls when it's like that. I used to. I can't do it anymore. I get nervous. So many people. All right. I like to have more space, fewer people. So remember, when the volume increases, there's going to be more space. When there's more space, it's less crowded. If it's less crowded, fewer collisions, which means there's going to be lower pressure. More space, greater volume, fewer interactions and collisions, less pressure. All right. And not only that, you could talk about the increase in the surface area of the container, right? Which would cause there to be fewer collisions on the wall because there's more space. But don't worry about that. So that in a nutshell is Robert's Law. If temperature is held constant, pressure will decrease when the volume increases, or the pressure will increase as a result of the volume decreasing. They are inversely proportional. They go opposite ways. Okay? So if this helped you out at all, subscribe, hit the like, comment below, let me know, share it with your friends. Chemistry with Coach Jakes. Take care. Have a great day. Be blessed.